In a glass case in a museum in London, there is a rod of stone about the length of your hand. It is granite, one of the hardest materials that occurs naturally on Earth, and around its entire surface, from top to bottom, runs a single unbroken groove that spirals down the stone like the thread on a screw. That groove was not scratched on afterward. It was cut into the rock when the rod itself was pulled out of a hole that had been bored clean through solid granite more than 4,500 years ago. The people who did that had no iron. They had no steel. They had no machine that any modern engineer would recognize sitting in a workshop. And the tool that cut this groove has never been found. Not a broken piece of it, not a worn stub, not a single confirmed example anywhere in Egypt. We have the hole. We have the core that came out of the hole. We do not have the thing that made either one. That is the reason this video exists. Because the official answer, the one in the textbooks, the one repeated on every tour, describes a method that is real and that works, and yet it does not fully explain the object sitting in that glass case. Stay with me, because the part everyone argues about is not the part that should unsettle you. For most people, ancient Egypt is pyramids and gold masks and painted tombs. They picture workers dragging blocks in the sun. They picture chisels and hammers and rope. And for the soft stone, the limestone that makes up the bulk of the monuments, that picture is basically correct. Limestone is forgiving. You can cut it, shape it, and carve it with copper and patience. Most people walk right past the real problem without ever seeing it, because the strangest objects the Egyptians left behind are not made of soft stone at all. They are made of the hardest rock in the country: granite, diorite, basalt, gneiss, stones so hard that copper will not touch them, stones that blunt modern steel, stones that today we shape with diamond and industrial machines. And the Egyptians were hollowing them out, drilling them, and finishing them to a polish before the wheel was in common use and long before iron was worked in the Nile Valley. The stone rod in that case has a name. Researchers call it Core Number 7, and its catalog number is UC 16306. It was recovered at Giza in the early 1880s by a young English surveyor named William Matthew Flinders Petrie, the man who effectively invented modern scientific archaeology. Petrie spent 2 years, from 1880 to 1882, measuring the pyramids with an obsessiveness no one had brought to them before. And among the debris on the plateau, he picked up the broken cores that ancient drills had left behind, the leftover plugs of stone that come out of the center when you bore a circular hole. He looked at this, one, under the standards of a trained engineer, and what he saw did not fit the story of copper and sand. Here is the first thing that should make you uncomfortable. The tool that produced this core should have been softer than the rock it cut, and yet the rock gave way, cleanly, in a spiral. Look at how the Egyptians described their own work, and it gets stranger, not simpler. In their art, in the painted tomb scenes, they showed craftsmen at their trades. There are reliefs of workers holding drills, twisting shafts weighted with stone to hollow out vessels, using bow drills to spin a bit. On the surface, it reads like decoration. Ordinary men doing ordinary jobs. But look closer, and those scenes are not decoration. They are technical documentation. They are the ancient world telling you, in pictures, exactly which tools were in the workshop. And that is where the puzzle sharpens. Because the tools shown in those scenes, the copper, the sand, the weighted drill, the simple twisting bit, are the tools that mainstream Egyptology says did all of it. The Egyptians drew their own method on the walls, and the method they drew does not obviously account for the object in the glass case. The people who first built in stone credited that knowledge to a man named Imhotep, the architect who raised the very first pyramid at Saqqara. Within a few generations, they had turned him into a god. They deified the man who taught them to work stone. You do not make a god out of a skill that feels ordinary. You make a god out of knowledge that feels like it came from somewhere else. So let us take the object apart the way Petrie did, because there are 3 clues here. And the first one you can see with your own eyes. Clue number 1 is the spiral itself. When Petrie examined core 7, he described a groove that ran around it in a regular, symmetrical spiral, so consistent that in one place he could trace it for 4 continuous turns without a break. Think about what that means physically. A spiral groove means the drill was sinking into the granite steadily as it turned, biting deeper with every rotation, the way a screw advances into wood. And then he measured how fast it sank. He found that the cut dropped about 1/10 of an inch for every 6 inches of travel around the core. One turn of the drill, and it had plowed 1/10 of an inch deeper into solid granite. Petrie, an engineer looking at this in the 1880s, called that rate of plowing astonishing. He was so unsettled by it that he tried to explain it 3 separate times in a single chapter of his book. Now here is the detail that turns a curiosity into a genuine problem. Granite is not one substance. It is a mix of crystals, mainly quartz and feldspar, and they are not equally hard. Quartz is significantly harder than feldspar. If you drill granite with a loose powder with sand sloshing around under a spinning tube, the powder wears down the soft feldspar faster and leaves the hard quartz standing slightly proud. The groove should be shallower where it crosses the quartz. That is the signature of abrasion. But Petrie recorded the opposite. On core 7, the grooves were cut just as deep through the quartz as through the feldspar. In his words, even a little deeper in the quartz. Loose powder cannot do that. Loose powder takes the path of least resistance. Only a fixed cutting point, something hard mounted rigidly in the drill, would plow to the same depth through every crystal regardless of hardness. Petrie's conclusion was blunt. This was cut by fixed jewel points, by something harder than quartz locked into the tool. And no such tool has ever been found in Egypt. Consider what the core even is, because the shape tells you the method. To leave a solid rod behind, the drill had to be hollow, a tube driven straight down into the rock so that it cut a circular slot and left the center standing untouched inside the ring. As the tube sank, the plug of stone rose up inside it. When they had gone deep enough, the mason snapped the core off at the bottom and lifted it out, a cylinder of granite that had never been struck by a chisel, its surface written all over by whatever had been rotating around it. That surface is the clearest record we have of the tool in motion. It is the negative of the drill, a cast of the cutting edge frozen in stone. And what it records is not the rough scouring of grit dragged in a circle. It is a clean, continuous, spiraling cut, the marks of an edge advancing with intent. Petrie also noticed the taper. Both the hole and the core narrowed slightly as they went down. Exactly what you would expect if the tube itself was being worn away by the pressure of the cut, finning as it descended. That is not decoration. That is a machine wearing under load. And the harder Petrie looked, the more the object behaved like the product of a process he could not name. For a long time, that observation sat quietly in an old book, a footnote in a survey most people never read. Then, a modern engineer went looking for the core itself. In 1999, an American machinist named Christopher Dunn, who had spent his career around industrial cutting tools, traveled to the museum in London and was allowed to physically examine core 7. He did something simple that no one had bothered to do. He ran his fingernail and a thread along the groove to test whether it was really one continuous helix or just a stack of separate rings. He came away convinced it was a single spiral, exactly as Petrie said. And then he did the math an engineer does. He compared that 1/10 of an inch feed rate to modern equipment. He contacted companies that drill granite for a living, and the answer he got back was that their industrial diamond drills, spinning at hundreds of revolutions per minute, advance into granite far more slowly than that. Dunn's claim, which he has repeated for years, is that the ancient feed rate implied by that core is many times faster than a modern diamond drill, turning at 900 revolutions a minute. Whether or not you accept his numbers, sit with the shape of the problem. A tool we cannot identify, made by a culture without iron, cutting granite at a rate we struggle to match with diamond. That is clue number one, and it is the smallest object in this entire story. Hold on to it, because the second clue is not one object. It is 40,000 of them. Beneath the step pyramid at Sakara, the oldest large stone building on Earth, there is a labyrinth of tunnels and shafts running for miles under the desert. In the 1920s and 1930s, the French architect Jean-Philippe Lauer worked through those passages, and in two of the deepest shafts, more than 30 meters down, he found a cache that has no equal anywhere in the ancient world. Stone vessels. Bowls, jars, plates, cups. Not a handful. Roughly 40,000 of them, packed into the galleries. It is the single largest hoard of stone vessels ever discovered, and many of them were made from exactly the stones that should have been impossible to work. Diorite, gneiss, basalt, granite, schist so hard it turns a modern blade. Some of these vessels have thin, even walls. Some are almost perfectly symmetrical, as if turned on a lathe, a machine the Egyptians are not supposed to have had. And some of the most difficult ones have a shape that makes no sense with hand tools at all. They are closed forms, hollowed out into a wide, rounded body through a neck so narrow you could barely fit 2 fingers inside. You cannot get a hand in there. You cannot get a chisel in there to swing. And yet the interior is hollowed, balanced, and finished. The walls a consistent thickness all the way around a space you cannot reach. Sit with that specific problem, because it is worse than it sounds. To hollow a closed vessel, you have to remove material from a chamber that is wider on the inside than the opening you are working through. Your tool has to go in narrow, then somehow cut outward, sideways, into the belly of the vessel, and come back out through the same small neck, over and over, shaving the walls evenly the whole time, in stone that resists steel. The Egyptian answer, in the reliefs, is a weighted drill, a shaft with forked stone weights lashed to the top to press it down, spun by hand, and for a wide-mouthed bowl in soft stone that works. It does not obviously work for a hard stone jar with a narrow throat and a rounded interior thinner than the neck it was cut through. Look at some of these vessels. Against the light, and the walls are nearly translucent. The stone worked down so fine and so evenly that the shape looks turned, not carved. A carved object betrays the hand. It has a favored side, a heavier wall, a wobble. The finest of these do not. They have the cold symmetry of something spun around a fixed center. And that is the word Petrie could not avoid. Rotating. A rotating appliance working the inside of a sealed stone vessel thousands of years before we think such a thing existed. Petrie saw these too, and the vessels affected him the same way the core did. Writing in his 1883 survey, he said the curves of the vases were so regular and the polish so fine that it seemed as if some mechanical means, some rotating appliance, must have been used. A rotating appliance. In the 1880s, describing objects from before 2500 BCE, one of the founders of archaeology looked at a stone bowl and reached, almost against his will, for the language of machinery. If you find this kind of buried history as unsettling as I do, take 1 second to subscribe, because what comes next is the part the tour guides never mention. The vessels are not even the same age as the pyramid they were found under. Many of them are inscribed with the names of kings who ruled before the step pyramid was built, rulers of the first and second dynasties, names from the very dawn of Egyptian history, and some from before it. The pharaoh under whose monument they were buried appears to have collected them as ancient treasures, heirlooms already old in his own time, which means the hardest, finest, most mechanically precise stonework was not the peak of Egyptian skill developed over centuries. It was there at the very beginning, at its most refined, and then it seems to fade. That is not how technology usually behaves. Skills are supposed to start crude and improve. Here, the most astonishing work sits at the bottom of the timeline, in the oldest layer, and no one can fully say why. That is clue number 2. And now the third, which is the one that takes this from bowls and cores you can hold in your hand to objects that weigh as much as a truck. Because the Egyptians did not stop at drilling small holes. They drilled at scale, and they left the evidence in their mistakes. Inside the Great Pyramid, in the king's chamber, sits a box of red granite, usually called a sarcophagus, though no body was ever found in it. Petrie examined that box closely, and on its inside he found the traces of how it was hollowed. The Egyptians had cut it out by drilling rows of tube-drilled holes side by side, right next to each other, then breaking out the cores and the stone between them, a technique engineers today call trepanning. And in 2 places, along the sides, the drill had run too deep. It had overshot, cutting further into the granite wall than the mason intended. Those errors are still there. They are a fingerprint. They prove that a hollow tube was driven into that granite hard enough and fast enough that it could plunge past its mark in one of the hardest stones on the planet. And remember where the stone even came from. That box and the whole granite lining of the king's chamber was not local rock. The Egyptians passed over the soft limestone, quarried right at the building site, and instead hauled red granite from Aswan, more than 500 miles up the Nile, block by block, specifically to build the one room they cared about most. They chose the hardest stone in the country, moved it the length of the kingdom, and then drilled and squared it as if difficulty were the point. You do not do that unless the material matters more than the labor. And the box itself carries the same silence as the pyramid around it. No body was ever found inside it. No inscription names an owner on its bare granite walls. The most magnificent stone container ever cut sits empty, unmarked, and hollowed by a method the culture never bothered to explain. Petrie found this pattern everywhere he looked. He documented core holes in diorite with the same regular spaced grooves as the granite core. He found a place at El Bersha where a whole platform of rock had been dressed down by cutting it away with tube drills roughly 18 inches across. The circular grooves overlapping where the ancient workers had simply chewed the surface off with drilling. 18-inch drills, cutting rock, and running through all of it, the same anomaly from Core 7. The grooves cut as deep in the hard quartz as in the soft feldspar. The steady spiral feed, the clean bite in stone that resists modern tools. Then there is the Serapeum, an underground complex south of the same site where enormous boxes of granite and diorite sit in rock-cut chambers. These boxes, with their lids, weigh in the range of 70 to 100 tons each. Their inner and outer surfaces are cut flat and their corners squared to a precision that engineers who have measured them describe in thousandths of an inch. They were somehow maneuvered down narrow, dark tunnels, lowered into cramped, rock-cut niches, and set in place with barely a hand's width to spare on either side. Picture the logistics of that. A single block of granite, as heavy as a fully loaded truck, its walls dead flat, its interior corners crisp, threaded through a passage in the dark, and dropped into a slot that fits it almost exactly. The precision is not just in the drilling, it is in the geometry of the whole object. The kind of tolerance that in a modern shop demands a machine bolted to a floor. Here, it was achieved underground, by hand, in rose granite, and then hidden. Whatever cut Core 7 was not a novelty used once on a souvenir. It was a production method, applied to hand-sized bowls and 100-ton boxes alike, across the hardest materials the country had. And still, the single most important piece is missing. We have thousands of holes, we have thousands of cores, We have giant boxes and drilled platforms and overshot mistakes frozen in granite. We have never found the drills. That is the wall this investigation keeps hitting. Not a cover-up in the dramatic sense. Something quieter and in some ways stranger. The method was never written down. There is no papyrus, no manual, no diagram that explains how the hardest stone was drilled and turned and polished. The tools themselves have vanished from the record, leaving only the copper saws and simple bits that work fine on limestone but struggle on granite. And the observations that might have cracked it were mostly left to gather dust. Petrie raised the question of the spiral core in 1883. For more than a century, only a few researchers seriously followed it up. The object sits in a glass case, examined by a handful of people, argued over, and otherwise left alone. When Dunn's machining theory was challenged, two examiners, an acoustics engineer named John Reed and a stonemason named Harry Brownlee, looked at core 7 and reported that the marks were not a spiral at all, but individual concentric rings, the kind you might see on any quarry core. Petrie said spiral. They said rings. Same object, same grooves, two trained observers, opposite conclusions, and the debate still is not settled. That is the state of the evidence on the most studied piece of ancient stonework in existence. We cannot even agree on what the marks are. Now, does any of this prove the wildest version of the story? That a lost civilization with electric machines or forgotten super technology built the vessels and the boxes and handed them down to the Egyptians? No. And the honest work here means saying that plainly, because the truth deserves better than hype. The mainstream explanation has real substance behind it, and it comes down to one man's decades of experiments. Denys Stocks, a British engineer and experimental archaeologist, spent his career actually trying to do what the ancient texts and reliefs describe. He built copper tubes, he fed dry sand under them as an abrasive, and he drilled. And it works. A copper tube spun against granite with hard sand grit beneath it will slowly grind a hole and leave a core. Stocks reproduced the tube drilling, the sawing, the coring. The sand does the cutting, quartz grit being harder than most of the minerals in the rock, while the soft copper tube just carries the abrasive around. That is a genuine result, and it deserves to be conceded fully. Copper and sand can drill granite, but concede it, and then look at what Stocks himself recorded, because his own numbers are where the mystery survives. The work was punishingly slow. In one test, cutting a slot into granite, his team removed stone at a crawl, and drilling granite ran many times slower than the same tools in limestone. The copper tube wore away as it went, sacrificing itself into the cut. And critically, the experiments that produced grooves did so with fixed points, not loose sand. When Penn Museum researchers ran the tests, they found that loose sand under a copper drill left the surface totally rough, with no fine cutting lines at all. The neat, concentric grooves only showed up when something harder was fixed into the tool, which loops straight back to what Petrie said in the first place. So the replication cuts both ways. It proves the Egyptians could drill granite with simple materials, given enough time and labor. It does not cleanly reproduce the deep in the quartz spiral of core 7, or the feed rate that made Petrie try 3 times to explain it, or how you turn the inside of a sealed vessel through a neck 2 fingers wide. Strip away every wild theory, throw out the lost civilizations and the machines from nowhere, and you are still left with a set of plain facts that are stranger than the fantasy. A hand-sized rod of granite with a thread cut into it that 2 experts cannot even agree how to describe. 40,000 vessels in the hardest stone in Egypt, the finest of them sitting in the oldest layer of history. 100-ton boxes finished flat and square. Overshot drill marks driven into rock that blunts steel. And a tool, whatever it was, that left every one of these fingerprints and then disappeared so completely that not one confirmed example has ever been dug up. You do not need aliens to be unsettled by that. You just need to look at what is actually there and refuse to look away. And if even the grounded version is true, the version with no lost technology at all, it still means something uncomfortable about the story we tell ourselves. It means a people we quietly file under primitive, working before iron and before the wheel was in full use, had reached a level of skill in the hardest materials on Earth that we struggle to match and cannot fully explain by their own recorded methods. It means the peak of that skill was already behind them when the pyramids rose, inherited, curated, buried like relics of a golden age. It means our picture of the ancient world is not a finished portrait. It is a sketch with whole pieces missing. And if we are missing the single most important detail, the actual tool, about the most examined stonework on the planet, then the real question is not just how they drilled granite. The real question is what else we have been walking past. Because the drilling did not stay in Egypt in our understanding, and it did not stay simple. Every time a new researcher brings a modern instrument to these objects, a microscope, a laser scanner, a precise measurement, the marks look more deliberate, not less. The grooves are too regular. The symmetry is too tight. Recent studies have even begun testing whether the ancient workers used chemistry or some form of assisted force to soften or speed the cutting, methods no one had seriously considered before. Precisely because the old story of copper and sand alone leaves gaps. We keep inventing new explanations because the object in the glass case keeps refusing the old ones. And through all of it, the one thing that would end the argument in an afternoon is the one thing we have never had: the tool. Find the drill that cut core 7, find the lathe that turned the diorite bowls, find one intact, and the mystery collapses into ordinary history. We have looked for more than a century. We have not found it. So here is the question that will not let go. If the Egyptians could cut a spiral into granite, hollow a sealed vessel through a neck you cannot reach into, and finish 100-ton boxes flat enough to measure in thousandths of an inch, all without a single tool surviving to tell us how, then what were they using and where did it go? A skill that advanced does not simply evaporate. Somebody knew how to do this. Somebody taught it, used it, and then the knowledge slipped out of the world so cleanly that all we have left are the objects it produced and the holes it left behind. That is not the story of a lost civilization. It might be something more haunting. It is the story of a real one, standing right at the start of recorded history, holding a technique we have spent 100 years trying to reverse engineer from its leftovers. The rod of granite is still there, in its glass case in London, the spiral still wrapped around it, sharp as the day it was pulled from the stone. 40,000 vessels still sit in museum drawers and storerooms, most of them barely studied. The great boxes still rest in their dark chambers under the desert, flat and square and silent. Everything the tool touched is still here, waiting to be measured, argued over, and photographed. Only the tool is gone. And whatever it was, however they held it, whatever bit into the quartz as easily as the feldspar and drove a thread into the hardest stone in Egypt before the Age of Iron, it is not in any museum, not in any tomb, not in any drawing on any wall. It is simply missing. And it has been missing in plain sight for 4,500 years.